during due course. And any questions that come in at the end that aren't answered will be answered via email. So again, if we all talk over each other, it'll be carnage like some other people's meetings. So just a reminder that the ITT Engineers YouTube channel, all previous sessions are up there. So this one will be up by close of business today. We're getting some good feedback for the sessions. Please keep them coming in. It's gaining good exposure for ITT and TDU and what we do at on the track program. So I have a program to cover the next 6 weeks, and I'm happy to say we've got some TDU guys going to do some presentations, and we've also got some of our delivery managers, and we're trying to get some of the night staff to do some as well. So I'm looking forward to that. So after the last presentation on innovation, we see recurring themes every week of collaboration and good communications appearing in all aspects of the business, detailing how closely you work with other disciplines across Balfour, Beatty, the wider business, and LU and TFL, the wider business. So last week's presentation was on the VCM, and a big part of that, I've been working on that now for about a year, to be honest. Plant approvals is a big part of introducing anything new and can be challenging. And I've asked Jordan Skee actually to do a knowledge sharing session as well on the common pitfalls that we seem to fall into. It can seem an exhaustive process with multiple departments, with fire, rolling stock, depots. We have to figure out where we're going to put this stuff when we actually introduce it. Plant and route approvals. So it does take a long time, but it does work and ensures absolute safety on our railway. So when we remobilise with our new defect-free delivery approach, which makes us lean, which is where we need to be in the new world. I was actually going through my emails. I was working on a Balfour Beatty laptop for a couple of weeks, and I had a string of emails, like up to 1,000 emails that I've missed on TFL. It was great to see after the knowledge sharing sessions, the interaction from the supervisors, delivery managers, and night staff, you know, conversations all about the defect-free delivery, how we can do things better. Lots of suggestions how we can improve delivery from the night staff. You know, some people are very vocal. Jamie Harris, Simon Atkins, Di Strong, interview, Dino DeFaria. You know, I really appreciate how these sessions are starting conversations and instigating change, because we all know change starts with conversation. So Ali's presentation is going to detail some of the techniques and challenges that we face renewing the tube. And hopefully, again, it'll start some people chatting, conversations, how we can improve stuff. So Walthamstow features in Ali's presentation. You know, it was being a really challenging delivery. You know, you speak to the engineers, it took us 24 hours to realign. You speak to the surveyors, it took 22 hours to realign. But, you know, we came away and we looked at how we could do things better. And what we learned from that was, at Walthamstow, we had independent legs. So once we moved one leg, we'd move every leg. And gauge was a big problem at Walthamstow. And something that a lot of engineers don't think about is field-to-field measurements as well, which is in your V's. So once we moved one leg, all legs moved. So that's why it took us so long. So at Camden, which was the following one, we tied them together, which was a good job because we overran at Camden 3 times, you know, with a lot less setting out time. So if we hadn't improved on that element of the works, you know, we would have had a major overrun instead of 20 or 40 minutes, whatever it was. So possibly only delivering one of the 4 possessions, which would have been a major setback for the track program. So lots of the senior leader team put their reputations on the line to deliver these type programs, you know, and they make, you know, ultimate decisions. So Alistair and John Lambert, Joe Keegan, clear the job with the readiness review. And we proceed to deliver jobs that have absolutely unique challenges. So these jobs are hard, and we deliver them, and we will continue to deliver hard jobs because, let's be honest, all of the easy jobs have been delivered. Delivering major works this year at Ealing Common and Acton Town. We're already in collaboration talking to the surveyors. At Ealing Common Depot, the engineers and the surveyors are coming up with the best ideas, trying to get more control. Depots aren't the best place for putting control in, but we'll have as much control as we can. We're looking at the various surveying techniques you can use, including the GPS and the UTS total station. So how we deliver every project, surveying and setting out is a major part of anything that we do. And we do work very collaboratively with our LU survey team. So a couple of slides down. Yeah. So ITT, we have the Kahoot quiz on these presentations. If you could familiarize with Kahoot IT or log on to Kahoot, they've been good crack and people have been very competitive. This week's will be on archaeology, not geology. So Alison used to dig old stuff out of the ground, which is an interesting part of the past. Feedback, keep it, the suggestions coming in, much appreciated. And again, let us know how we can use this forum better to increase collaboration across the whole TFL business that we work in. Live link and YouTube channel links are on the invite, so everyone can have a look at that. So for this week's presentation, Alison is going to give us an insight into stuff that they do that I didn't actually know, that actually they've a lot on their plate. So Alison has worked for us for years, and we all know and love to see her on site. Generally, she's fighting with every engineer on site for 2 millimeters, even though we are already within the tolerances in class 1. She'll push everyone to get it right. Class 1 isn't good enough for Alison. She wants it right. So she started her career as an archaeologist, as I said. Rumour has it she dug up ATF on one of her assignments. So she started in the railway in 2008. She worked with Tritech and AECOM. She joined Track Partnership in 2012 with Balfour Beatty around the same time as me. And a couple of years later, she moved over to LU, providing survey coverage TP and TDU. She is now the senior engineering leader for Track at TFL, and she does a lot of work for ITT and much more besides. Fun fact about Alison is she's a bit of an adrenaline junkie. She loves climbing mountains in her spare time. I'm not talking about rambling or hill walking, which I enjoy, and other people like Owen. The year before, we delivered Walton, so she went snowboarding in Afghanistan. Not everyone's choice of a holiday destination, but I'm sure everyone would like to go once. So on that, I'll pass the presentation over to you, Alison.
Thanks very much, Damien. Cheers for that. Yeah, so welcome to P-Way Surveying, and I'm just going to correct you slightly, Damien, because it is a joint survey team. We've got Balfour Beatty colleagues and TFL all working together in the survey team. In fact, that's one of the Balfour's surveyors there, Andy on the trolley with his cheeky little face. I love this picture. It's probably going to come up more than once in this presentation. Yeah, okay, so let's go through the agenda. What I'm going to have a talk about today is basically when we get involved during a project, which is all the way through, basically beginning, middle and end. We're there the whole way through. What we do during that time and how we do it. And then, as Damien said at the end, we're going to go through a bit more in depth of some of the challenges that we face, and Walthamstow was one case in point. Okay, so when are we involved? Throughout the whole life cycle of a project. So we get involved right at the very start, from the survey for the design. We then verify that. We're involved in the setting out on site quite often, then the follow-up TAMP following a BTR. And then at the end of the project, we do the as-built, which is feeding back into the made and the handback. Okay, so starting from the start, the survey for design. We go out and we first of all establish a control network in the area for the project. So this is on London Survey Grid, based on London Survey Grid, which means that every project is all tied into the whole rest of the London Underground network, which is important. It is very important that the control that's established at this point in time is carried the whole way through that project, and that control is used the whole way through, because the tolerances that we're talking about is millimeters, so we have to make sure we're using that same control. So what we do out there is we survey the existing track and features, so everything that's out there to start with, and we also push a scanner trolley through for clearance data. Okay, this is an example of a survey for design. So this is actually Uxbridge. As you can see, it's pretty complicated. I don't think you'll be able to see the details there, but you can see we pick up all the signalling assets. We've got the rails, we've got the Conrail, we've got any structures such as bridges, things like that, all of the catch pits and the drainage, cables, anything that's out there, basically, we'll survey that. And for places like this, for jobs like this that are complex, like P&C, it can be months on site doing the survey for the design, and then a considerable amount of time in the office after that, processing all of the data and creating all the files. Okay. Right, so this is an example of some of the scan data. So this obviously is not Uxbridge, this is a tube tunnel, but it gives you a good example of point cloud data that we produce from pushing a scanner along the track. So from this, you can see there's awful lot of detail there. It's a very useful information for the designer to use, because they can see absolutely everything. They can see what it is that is actually causing their clearance infringement. As you can see here, the tunnel appears to be causing a bit of a clearance infringement. That's the red. So hopefully with their design, they will improve that clearance. Okay. Scan data can also be used for other things as well, though. So we have two things that are available on the One London network, so TrueView and Jetstream. And these are basically point cloud data that have been uploaded. You can access it through the GIS. Anyone can access it, but you need to have a plugin added to your profile. So if you go onto Platform, as it's called now, so our new platform, and you Google, for want of a better word, TrueView, it will tell you on there who you need to contact and how you can get it added to your profile. Then once you go into the GIS, you'll see these little yellow triangles. If you click on them, you can see TrueViews, and you can basically, it's like you're standing on site and you can rotate around and have a look as if you were actually stood out there. It can be very useful. It gives you a good idea of the site, better, potentially in some cases better than a photograph. And you can also do measurements. So within the software, you can kind of see it, the purple lines, is you can click within that point cloud and take measurements. So if you were trying to plan a job and maybe you wanted to see how much room you've got in the set for storing materials or something like that, you can go in and use the data for that. Now, this doesn't cover the whole network at the moment, but it does cover a fair amount. And for places like Camden, when we did that, we did scan that site, and so there are TrueViews available for that. This data generally comes from static scanning, which where we put a scanner on a tripod, which we don't do for every site. Whereas what we do for every site is push the scanner on a trolley, which gives you the clearance data, which is slightly different. But I thought it was worth bringing this up because it's useful. Okay, next one.
Sorry, before we move on, there's a question that's come through.
Yep.
So obviously this is very detailed and it covers some of the network. Do our engineers use this for planning purposes?
Some of them do. James Field has previously, I know that. So some people have used it. I don't think enough people know about it, which is why I put it into this presentation, even though this is not data that we wouldn't necessarily create for all of our design surveys. So this data tends to come from other projects that have been done. So it might be where like a civils project is designing something and they want a proper model of an area. This data is not really, it's not necessary for a design survey. So the value added of going and spending the extra time doing the static scanning, it doesn't really add enough value. But where it exists, then it is useful to reuse this data. And there may be some, again, like Camden, there might be places where actually it is adding enough value for us to spend the time doing it.
Okay, thank you.
Okay. Right, so next thing, so moving on to verification survey. The reason that we do it, we need to revalidate the design basically. So quite a few of the projects that we work on, the survey for design might actually have been done like 4 years ago maybe. A lot can happen out on our network in 4 years. So before we go out, we don't want to go out and do the BTR blind. We want to go and check that everything's still valid. So we go back out on site. This is maybe 7 weeks prior to the BTR, something approximately like that. We go and check the control first of all. So parts of our network, are quite stable in terms of like ground movement. So in the tube, things are generally quite stable. In the subsurface, generally, apart from when crossrail tunnels underneath us, then it's quite stable. But places that are more open out on our network might only have cable runs, maybe up on an embankment for us to install our survey control on. And places like this can sometimes suffer from seasonal movement. So you might get a heave of the embankment, and it means that that location of that control has actually moved. And again, it may be 20 mil, but 20 mil is quite a lot when you're talking about track. So first thing is we go out and check the control. We might add extra control, particularly in the subsurface, for example, where we're going to be using that survey control for the dozing machine. We don't have very good lines of sight in the subsurface, so we install additional control, which might be just targets up in the roof. Other parts of survey control could be nails on a platform, or it could be spigots that are up on the wall in a tunnel, for example. So we've enhanced the control. We're going to mark up the site. So we'll mark up the site chainage on site so that everyone, when they're during the BTR, we know where we are. It's very important. We install reference markers, so whether that be more permanent reference markers like monument pins, or something that is a little bit more transitory, like just targets that might be stuck to a cable run. We also use the back edge of the adjacent 6-foot rail if it is available, because that is a good solid reference to use. So we survey the existing track again, we survey these references. We may do a GPS calibration if we're going to use GPS for the dozer. We mark up tow lines, so if we're doing P&C, then we'll mark up exactly where the new tows need to go. And then we'll take all this data, we'll take it back to the office and process it. We then use the design software to compare the survey that we've just done to the design alignment that the designer has produced. From that, we can tell whether there has been any movement of that track in the intervening time. We can tell whether the tie-ins still work. So we want to make sure that where we're cutting into the existing track, that tie-in of the alignment still works, is still valid. We're not going to end up with a kink or anything like that. So we check that. We run the references against the design alignment, which gives us offsets from that, which the engineers will then use to set out the track on site. And we produce tech sheets, which are just spreadsheets, which will tell us what the tie-in looks like, and also the offsets, so horizontal and vertical offsets from those references to the new design position of the track. Okay. And then the setting out. So on site, if we have a plain line BTR, then most often the engineers will be setting that out themselves using the references that we've installed. But we also have so first of all, you've got the formation and the ballast. So we want to get it right from the start. So if you're going to get a good quality piece of track, then you want to get it good quality from the start, from the formation, building up to the ballast, and then the rails. So to get a good quality on the formation and the ballast, the easiest way of doing this to get the best accuracy is to use 3D machine control. And the way that we do that is that in the office we create a DTM, or a digital terrain model, which is basically just a surface, and it is the surface of the formation that we're aiming for. That's what we want. That's what we want to cut to. That is based on the design alignment file that the designer has produced. So that's for the formation, and then a similar thing for the ballast. So the formation obviously includes the depth of ballast that we need, so different for P&C or for a BTR, and the crossfall that we want, whether that's going to the cess or the 6-foot or whatever. And then for the ballast, that will include the cant that's on the track as well. So this file is uploaded into the dozer, and the dozer we could be using GPS, or we could be using UTS. So UTS is a total station. UTS, it's the same thing, just a different name for the same thing. And whichever of those two methods we're using, that GPS or UTS will be basically giving the dozing machine its location in space. So it's constantly connected to the dozer, and it's constantly feeding up these updates of the dozer's location and its location relative to that design file that's uploaded in it, so that the driver can tell whether he needs to lift the blade, lower it, or whatever to achieve the right design. Okay. Right, so they're setting out the rails and panels. So as I said, the engineers will quite often be setting out, if it's just a plain line, they'll be using the reference points. So that top picture is a monument pin. That's one of the more permanent things that we would install. So that would be if there is a permanent structure out there, like an overbridge, or if you're in a tunnel. And the engineers would just use a tape and a 5-point laser to get those offsets, to measure those offsets, or maybe a Mephisto trolley as well, which again just is a laser which measures, sits on the track, and it measures to the pin and gives you an offset. Sorry, can you get my set right? Where we get involved, so the survey team do get involved in setting out on site. Sometimes, so generally, okay, when it's more complex sites, so like P&C generally. This is, I think, Wimbledon. So this is obviously ballasted track, and this is a modular P&C layout. So in some ways, quite easy. It's like it's coming in a big panel. You just got to get the panel in the right place. The downside of this is that these panels are extremely heavy, and you really want to be getting it in the right place again. So once this layout is installed and tied together, it's a very heavy layout. So tamping it, even with tandem tamping, can be quite difficult to actually get the design that you want if you've got large lifts or large sloughs either. So we really want to get it in the right place. So that's what we're aiming for, is that tight tolerance, and also getting the toes in the right place is a very important thing. So in terms of chainage along the track, we want to make sure that we're getting the toes in the right place. It's important for the signalling, or it's also important for the alignment, because if you, particularly with the turnout, a small difference in chainage can mean that as you're trying to chase the alignment across the turnout, the differences are getting larger and larger as you head along the alignment. So yeah, thank you. And then the next challenge, setting out, so also rails, slightly different challenge. This is the deep tube P&C, as Damien alluded to earlier. This is possibly Camden or Paddington, or there have been a lot of them since Walthamstow was the first one. It was the big one. It was a massive challenge, but we have done a lot of these since then, and a little bit they blur into one. So we've done Paddington, Liverpool Street, several Camdens. And here the tolerances are even tighter, so we're going to put this into concrete. It's going to stay there for a very long time. So the tolerances are very tight. We want to be plus or minus 3 mil. We'll go into this a little bit more later, but what we use in this case is still a total station, but the total station is tracking this survey trolley that you can see in the foreground here, that yellow thing. That sits on the rails, and as the total station tracks that, it gives us lifts and sloughs, so the horizontal and vertical movement needed to put that track to design for each rail, so we can get a really tight grip on what we need to achieve. Okay, and then the follow-up tamp. So after a BTR or any ballasted installation with a P&C or just plain line, we will have a follow-up tamp that rolls on from that. Hopefully only one, but possibly several follow-up tamps may happen over the course the lifetime of this project. So prior to the follow-up tamp happening, we would go back out and resurvey that track again. Again, we would check the control, make sure nothing's happened, particularly if it's been a long time in between. But we would resurvey that track, and then again use the design software to compare where the track is at this moment in time to where the design alignment is. And hopefully there will be fairly small adjustments that we need to make to that track. So as you can see here, the tamping information on the right hand side, it's shown is that the sloughs are almost all under 10 mil. The lifts, we've got some lifts there of up to sort of 20-25 mil that we need to achieve there. And then at the bottom, it just shows the offsets from whatever target or like reference that might be. In this case, it's targets that are probably on a cable run, and it gives the offset in horizontal and vertical. And these are exactly the same type of tech sheets that we would have issued at the verification stage as well. Okay, as well, so the end, hopefully the end of the project. Once we're happy that the track is into its final design position, we will go out and resurvey the track as an as-built. So at this point in time, we also survey all the newly installed track features. So again, whether that be any signalling on the Conrail, everything like that. And from that data, we then process it in the office to produce a red line drawing. So that will show all the features, and we also create another tech sheet, which hopefully will show again the differences to the design, which hopefully this time are within tolerance. You can see on this example here, we are slightly out of tolerance for the cant. These tech sheets are set so that they will show up anything that's outside of the tolerance for that type of track. So whether that is deep tube or subsurface, the different values that correspond to that. And also at this point, or earlier in fact, but they have to be done by as-built stage, is the datum plates. So any permanent reference points that we put in the permanent monument pins, we install datum plates next to all of those, which again have the same information in terms of it's the offset, the design cant, etc., things like that. And that's for the maintainer to then use going forward to maintain that track to that design position. Okay. And here is just a larger picture of this beautiful as-built, which is also Wimbledon Park. So yeah, just gives you an idea of what we do. Okay, so how do we do it? The kit that we use. So I've talked about total stations quite a lot so far already. We also do digital levels, which is for surveying or measuring the height when we're checking or installing the control network. We would level through any ground control. We use GPS. We also use cant gauges. We use the Amberg trolley, which is the survey trolley that was shown on the picture of the deep tube, and we also use scanners, whether that be generally for clearance. Most important thing about any of this kit we use, so whether it's a cant gauge or a total station, is that it is in calibration and that it is fit to use. So it hasn't got, there's no loose bits on it. It is solid, it is good quality, it's ready to use, it is going to give you a good answer. And that is the case again for any surveying equipment that any engineer might use. You need to check this calibration and you need to check it before you use it on site. Okay, all right, next. Total stations, we'll keep going about total stations. So what do? They measure angles, basically. So that's horizontal angles and vertical angles, and they also measure a distance. So from that, if you've got control points already on site which have known coordinate positions of those control, then the total station can calculate its own position from the existing control points that are out there. Whilst when we're installing the control, we would either use existing control that's already out there on the network, because there is an awful lot of control already out there, or if there isn't, then we might use GPS to install a baseline out there and work from that. One of the downsides with a total station is that it does require a line of sight. So it requires you to be able to see your control points, enough control points from where you're set up, and also to be able to see whatever it is you're trying to survey, whether that be behind a tamper or whatever, or setting out panels, whatever it might be. When we use the total stations during, say, verification, we post-process that data in the office to produce a 3D coordinated model of the track. Okay.
Ali, just another question that's come through.
Yep.
In regards to, I guess, the kit that we use, do we as a project own them, or do we hire them out from, I guess, an external supplier and maintain it and stuff?
Yeah, so at the moment we own some of it and we hire some of it. So we within Track Program we own some of the Trimble kit. We have, I think, we have two sets of each. We have two sets of GPS base stations, and we also have the total stations with UTS as well. So those can certainly be used by engineers during a BTR. We sometimes hire additional kit, but yes, we do own our own kit, so we should be using that as much as possible. It's important that people look after it and don't lose bits of it.
Okay.
Yeah. Okay, so this is the bit where I bang on about geometry. A lot of you have probably heard me bang on about this previously, but I'm going to do it again. If you're out on site and you're setting up a total station, one method of doing it is to use what we call a resection. So It means you can kind of set up the total station wherever you want to be, and then you shoot to a number of control points, whether that be, generally it'll be spigots that are mounted up on the wall or something like that. It's important to get good geometry in this. So what I mean by that is that you want balanced angles. So what you don't want is for there to be a very narrow angle between your control points. You want a nice wide angle between your control points. You want to be sat somewhere in the middle of your control points, preferably. You want to have a reasonable distance away to your control point, so you don't want to shoot something that is only 10 meters away. But you also don't want to mix things that are a very long shot sight one way and a very short sight the other way. So this is the ideal world. That top one there, that's the ideal world. This never happens on the railway. One is that railway is quite a long, narrow thing to start with most of the time. And then when you add in machines and people and things, it does get very difficult. It's a lot easier at verification survey stage, I will say. Like the pictures I had at the verification one is like, it's a nice clear site, you've got options. It's very difficult during construction. It is. I appreciate it. I know that it is, but you need to try and get as much as you can work towards this. The minimum number of control points you can use for a resection is 3. 3 is the minimum. Try and use more, but 3 is the minimum. 2 points is not a resection. That is just a bad thing. You notice from the bottom one here, I couldn't even bring myself to put a 2-point resection in as a example of bad practice, because it's so bad, it's very bad. There's no redundancy in a 2-point resection. You can put whatever you can set up a total station and shoot to 2 points, and the total station will give you an answer, but it probably won't be the right answer. And because it has nothing else to check against, it can't tell you how wrong it is. So you may proceed with this and be in a very wrong place. I've had people be on the wrong track on a twin track section and ring me and say, this design says it should be on the other road. It's like, no, it's because you've done a 2-point resection. It really can be that bad. So this bottom one here is just an example of what you're trying to avoid, which is very short sight one way and then a very tight angle between some other control points. And particularly if you were then trying to shoot over to the right, you're not within your control. You can't tell how out of tolerance you might be by the time you get to where you're trying to survey. So if your setup says, oh, it's only 5 mil out to that control point, but you then shoot 100 meters the other way, it's just going to, that error that might be in it is getting exponentially bigger and bigger. By the time you get to where you're trying to survey, you might have 20 mil of error, but you just won't even really know about it. Okay, I'll stop banging on about that now. Okay, next one. GPS. So GPS use satellites to coordinate its position. This is great on the right site. So on the right site, GPS is brilliant, but it does require a clear view of the sky. It needs to be able to see those satellites. So in central London, it really doesn't work very many places. There's lots of big buildings, and even sometimes when you go out more to the open sections, railways are a place where people like to put lots of trees along the side of it or something like that. So if you've got a lot of trees overhead, again, it's not going to work great. The accuracy is going to get lower with the fewer satellites that it can see. So if you've got a nice open site, then it's a good time to start using GPS. The brilliant thing about GPS is that it doesn't require a line of sight to the dozer. So you can set it up, you can set it up out of the way. You can set it like maybe up on the end of a platform or something like that, but out of the way of the general hubbub of a construction site. You can protect it so that no one's going to trip over the tripod, whereas with the total station, you've got to be in amongst it all, and you've got the possibility of people knocking the total station, putting it out of level, which means that you need to set it up again, because once it's off of level, it's no use to anybody. So GPS is definitely better for that. If we're going to do a GPS site, we go out and do the preparation for that, which means setting up the base station out there, and then we calibrate the site. So the rover, which is the thing on the left, we go and survey all the ground control that's out there with the rover, and that has then corrections from the base station. So we process that in the office. That calibration file then goes onto the dozer, and when the dozer is receiving the updates from the base station on site, those corrections are added into the data. So it's definitely on the correct design for that site. GPS is generally a slightly, the worst accuracy for GPS is the height accuracy, and it is getting better all the time, but because height is the main thing we're after when we're dozing, whether that be for the formation or the ballast, is the height is the bit we want to get correct. If we've got a site where we need high accuracy, so more quite often for P&C or through platforms as well, where we haven't got a lot of leeway in the height, we would tend to use a total station for those sites, and GPS more for sort of open sections out in the middle of nowhere. So, okay, right, the software that we use, survey processing software. So there is quite a lot of survey processing software. I picked on a few of them. The main one that we use is SCC. This is for what we download our raw data from the total station into, and we process the angles and distances with the control to produce a survey model. StarNet is the thing that we use to calculate our control networks at the start. We then move on to using the design software. So Bentley Railtrack is the design software that LU uses. And we use that software, as I said, to compare the survey that we have, the survey that we've done against the design alignment file that the designer has produced, because that can then tell us the difference between our surveyed position, the current position of the track, and where it needs to move to. And then the Trimble, so Trimble Business Centre is what we use to create the digital terrain models for the dozer. And it uses the same design alignment file, which is an ALG file. So we upload it into the Trimble software. And then we take things like, so we need the construction depth, so from the top of the rail to the bottom of the sleeper. That measurement goes in there. We would then need to take into account what the depth of ballast is that we need to achieve, which again for P&C will be different. So the crossfall, the cant. So we put all of that information in, and we then create offsets from that alignment file to the level that we need for the DTM, and we triangulate that, so we end up with a surface. So it's quite a simple surface for the dozer to follow, and then we export that and upload it onto the dozer. For P&C sites, these really can be quite complicated. One, because you're going from having the deep depth of the P&C bearers to then just the plain line sleeper, different depths of ballast, different crossfalls, and quite often converging or diverging tracks. So it is complicated, but it is useful to build that surface in the office prior to going out on site, because we can then predict how the dozer might react to it on site and plan before we get out there, right? How is this crossfall really going to work? Are we going to have to dig it very deep to achieve a crossfall across the whole, across like both roads, for example? So it usually takes quite a lot of toing and froing with the engineers to really get that to be the best that it can be before we get out on site. Yep, and then Amberg Rails, the other one that I listed there, sorry, just very quickly. Amberg Rails, the last one, which is what we use for the trolley data, so whether we're processing it or we're setting out on site, that's the software you use that. Okay, all yours, Red.
Thank you, Ali. I was a bit trigger happy there.
That's all right.
Hello, everyone. Again, it's time for the Kahoot quiz. I'm just going to share my screen. Bear with me. Oh. So again, if you guys can all log into kahoot.it, the PIN number for you to join the game is 877168. If you guys can all join, please. I think I'll wait for 10. Pete Johnson, nice to see you again. Terry Chage, Dan, yep. Yep. So the pin is 877168 on kahoot.it. And in honor of Ali, it'll be kind of like a history themed one. Cheers, Ram. I'll wait for 2 more players and then I'll start. You can also join when I start the game. The code is 877168. I'll give it 10 more seconds and then we'll go. Okay, we're going to start it. So yeah, this is the knowledge sharing surveying quiz. I hope you guys are ready. There's 10 questions. So question 1, the rise and fall of the blank empire is one of the most consequential events of ancient history. Is the blank the Roman, the British, the Antarctic, or the United States Empire? I have 5 seconds to answer. The correct answer is the Roman Empire, and 9 of you got it right. Well done. Terry Church is in the lead. Well played, Terry. Question 2. How was the ancient Roman city of Pompeii destroyed? Was it flood, volcano, hurricane, or war? Which of those was it? Again, if you guys go on kahoot.it, you can still join. The code is 877168. The correct answer was, in fact, volcano. Let's see who's in the lead now. Cloudy is in the lead with G in second place. Question 3. Which country is famous for its amazing and very old terracotta army? Is it Indonesia, China, or the UK? 10 seconds to answer. It is indeed China. 9 of you got that one right. Let's see who did it the quickest. It's Claudie. Well played. Question 4. Julius Caesar was a mighty Roman emperor, but how did he die? Was he attacked by a lion? Did he drink too much wine? Or was he murdered? He was indeed murdered. I think by his nephew as well, so very interesting. Cloudy's still in the lead. G and Pradeep in close second and third. Question 5. I can't say this word. Tenochtitlan was a massive capital city in which society? Was it the Aztec, the Mayans, or the Japanese? Bit of a tricky one, this. It is actually the Aztec Empire or society. G is now in the lead with Pradeep in second place and Pete J catching up in third. Question 6. Ancient Rome began growing in the area that is now blank. Italy, New York, or Iraq? 11 seconds to answer. It is indeed Italy. Well played. Pradeep has taken the lead. Question 7. Which great warrior conquered Egypt in 332 BC? Was it Joan of Arc or Alexander the Great? It is, in fact, Alexander the Great. Pradeep still in the lead. Question 8. The Mayans were a powerful civilization in the area that is now Uganda, Guatemala, Greenland, or Colombia? Bit of a tricky one here as well. 10 seconds left. It is, in fact, Guatemala. 6 of you got that one right. G is in the lead now. Pradeep has fallen back to second. So question 9, the Aztecs were noted for their participation in which ceremony? Human sacrifice, surfing, or waterboarding? It was indeed human sacrifice. Doesn't sound too fun. G is in first place, Ram in second, and Pradeep in third. The final question, the surface of Egypt's ancient pyramids were covered with what? Was it gold, diamonds, platinum, or simply white limestone? 10 seconds to answer. It was indeed white limestone. A bit of a letdown, but so in the podium, in third place is Terry Church. Well played. In second, we have Ram, and in first place, we have G. Well played, G. I'm going to hand it back to Ali. Hope you guys enjoyed that.
Cheers, Vid.
There you go, Ali.
Cool. Thank you. Next one should be challenges, something like that. There we go, challenges. Challenges. Many challenges. Okay, so you can see on this one, just picked a couple of things, which is the gorgeous underfoot conditions that we have there, and also just a lot of people. There's an awful lot of people on site when we're trying to do stuff. Yeah, all right, let's have a look at the next one. Cheers, thank you. So tamping, just a couple of the challenges that we sort of face with tamping. So if we are out on site as a survey team tamping, then it is usually for something that is a bit more complex, such as PNC tamping, which quite often is tandem tamp. And you can see from that picture there that when you have two tampers in, for example, a subsurface tunnel, there's not a lot of other room down there, not a lot of space to work safely particularly, but not a lot of space to set up at all. So one, you want to, again, as I said, you find somewhere that you can set up, that you need to be able to see have a line of sight to your control. So that's one thing, and then also a line of sight to where you're actually working. So that can be quite a challenge when we're on tamping sites. The other thing is, so the other picture we've got there, you know, that's a lovely site out in the blue sky. It's beautiful, but still the only place to set up that we've clearly found at that point is in the 6 foot, which is right next to the tamper. And one thing that tampers do is vibrate quite a lot, and one thing total stations don't like is the ground vibrating quite a lot, because it causes them to go off level, and say, as I said, when it's off level, then it's not use or ornament, so we have to continually be setting up. So places like this, we've got to be checking and checking, and you've just got to make the best of what you've got, but it can be quite a challenge. Okay, next one. So I just thought I'd stick this one in because it's not always ballasted track or deep tube. So we also get involved with long timber bridges whenever ITT are installing them. It's, again, slightly different challenge, usually very tight tolerances. You're trying to get it right first time, so you're not having to lift timbers in and out. I think this is somewhere between Baker Street and Finchley Road, if memory serves. And then we'll move on to the main event, which is setting out in the deep tube. As I said earlier, tolerances are very tight for setting out in the deep tube. You've got to get it right. So what we do is try and get it right from the start. So this on the left is the, again, I cannot remember which layout this is, but it's very colourful. We tend to try and go up to the wherever the yard is that is being built, so whether that's up with Progress Rail or with Lily Bridge, and we survey the track as it is set out there. So this does help us to identify if there could be any differences to the geometry that's actually been built versus the geometry that was on the design. So if we can find things at this point, then we can either resolve them, or at least we know what we're going to be facing on site. And there on the right is the start of lifting the rails in. So first of all, so going sort of back a step from this, the digital terrain models that we create for the dozer, we also create them for the minimum breakout depth for these these deep tube sites as well. So we want to make sure that we're going to have enough minimum depth of concrete. So we want to make sure we've broken out enough, but not spend time breaking out if we don't need to. So we create that same digital terrain model, and that can be used with a total station, and just so you'd have a prism on a pole to be able to go across that whole surface and check that we've achieved the right depth. Once we've done that, then we start laying out sacrificial wooden sleepers. So this is what the rails will then be lifted onto. So we want to try and get the position of these rails as close to the design position from the start. After this point, when they're on these sleepers, then we're going to put them onto jigs, and the jigs can be used to lift and lower the track, and also to slew the track, so make the horizontal movement. But making horizontal movement, particularly the horizontal, is difficult. Once it's all up on the jigs, it's very difficult to do. So the best answer to this is to get it as right as possible right from the start, just all the way through. Aim for as close as you can get it to the design position. Okie dokie. I think the next one, yeah, so this is when the track is up on jigs. it's quite difficult to see, I think, from these, like, what is going on, because there's an awful lot in this photograph. It's possibly also slightly blurry, but it kind of gives you a good idea of the chaos, is that the right word? The complexity of the site when you're working in the deep tube. It's a small area, there's a lot of people trying to do a lot of jobs at the same time in a small space in a very short amount of time. So you have the track up on the jigs like this. We use acro props and jacks to try and get the horizontal alignment. This again can be a challenge in itself. So we did try some innovation where we attached the acro props to the tunnel rings. So this was there was good theory behind this, but the problem, that was supposed to give us a push and pull effect, which is one of the things that we suffered with at Walthamstow, was that we could push the track, but because the whole layout was there across the whole cavern, to get us, if we wanted to go towards the tunnel, we were trying to push from the other side, which was ridiculous. So we wanted a pull action if we could. We tried this at the next site that we had, but what we found is because of the angle that the acro prop was then at, as you tried to slew the track, it then also lifted it, which was not useful. And the other problem with that was that the acros were then in a particular place, whereas what you tend to find is that the alignment of the track can be fine at the point where you've got your acro prop, and then 5 meters further on is where you actually need to try and slew it across, because that's where you've got the difference to the design. So, you know, we keep trying to innovate. We've tried things, some of the things haven't worked, we've moved on to something else. So acro props are there to make the small fine adjustments, and also to hold the track in position before and during the concrete pour. We also use them to try and hold the gauge in some places. As Damien said, we have created bespoke gauging bars that are supposed to hold the gauge, which should allow us, so again, this is a Delcor layout, which should allow us to push from either side, and we would hold that gauge rather than pushing one rail and then moving one rail, but then having to move, like just tightening up the gauge basically, and us having to move the other rail. We still haven't found the solution for this, so it's getting better, I would say. It certainly makes it easier to do the track alignment, that the gauge doesn't move too much. You are slewing both rails together, but we still find that we have gauge that is either too wide or too tight, and we have to remove the gauge bars. So if anyone is out there and has a bright idea for how we hold the gauge, particularly through the switch and through the crossing, where you can't just put something across a 4 foot. If it's just a 4 foot, just plain line, then you can hold it, it's fine. It's where we've got extra rails in the way that is the major problem. Also here you can see that we've got a drainage channel or a drainage pipe that's running down the 4 foot, so the underfoot conditions, either for access and egress, trying to manual handle across all of these, can be a real challenge. And then yeah, you can see there from just the number of people that we may have on a site, that it can be quite a challenge to everyone to work around each other, and for us to maintain a line of sight when we've got a total station that we're trying to use to set out the track, which I think it will show in the next slide. Yeah, here we are, a beautiful survey trolley again. So the total station is sitting at the other side, just beyond the crossing nose there, and we need to have that line of sight to the trolley to give us those live updates. So it'll be continually, it's making continuous readings all the time, and it's giving us the lifts and the slews to the design. Okay, next one. So this one I had to put in because it's a beautiful picture of our lovely Damien McNeice there, working, maybe standing, certainly. And the survey trolley, and then a little bit of a zoom in on what we can actually see on the screen. So these are the millimeter movements that we need to put each rail to the design position. So it's looking quite good on this one. We're looking for plus or minus 3. Just got one rail that's the problem, but as you can see with this, the problem is the gauge, because the left hand rail is fine and the right hand rail is not. So the gauge is the problem, which it always is. So when we start this process, it is an iterative process. We can't try to put the track to the design position all at one go. It just doesn't work. It just definitely doesn't work like that. And anytime you move the track, the bit behind that you've just done will move slightly, because it's all connected together, it's all going to move. So the method that we use is we do a first pass, we run through the whole layout, and we try and bring it to within 5 mil of the design. So we want to be within 5 mil of the slew, so the horizontal, and preferably about 5 mil low. It seems to be a lot more difficult to lower the track. It's quite easy to lift the track. We have it on the jigs, it just rises up on the jig legs. So it's quite easy to lift, but it's difficult to lower. It doesn't want to sit back down. So first pass is within 5 mil, and then the next pass through is to try and get it to design. So as I said, we're aiming for plus or minus 3. That's on the gauge, the cant, the slew, the lift, everything. But we also want a smooth variance. So you don't want to be at one set of base plates and have, as it says, that you're only 3 millimeters away from design, but to the left. You don't want then the next set of base plates to be to the right, because that's a 6 mil over quite a short space of track. So we're looking for 1 or 2 mil in variance again between each base plate, and so in all things, so in gauge, in cant, in slew. So there is quite a lot of information to take in all at the same time and push it through again. So we will do that pass and try and get it all to design. As I said, you will then get changes behind you as you move that track. So we would then need to go back and check that anything that we have done hasn't then moved the track in front. So we will go back and do one final run through, and hopefully what you find at that point is that all of the track is to within plus or minus 3, and you'll make those final little changes, and then after that we go through on a recording run and we record the as-built of where we've left that track prior to the concrete pour, because we want to know where we have left it. The risky part, which actually, Vid, if you can go to the next slide, thank you. The risky part, one of the risky parts for us, is that after we have put that track to the design position and we are happy that it is all to class 1 tolerances, we then need to wrap the track in plastic to protect it before the concrete is then poured on it. And also the concrete pipe to deliver the concrete also has to be extended further into the layout, which is sitting also on the jigs that the track is sitting on. And this necessarily means that people are going to be moving around the layout, or possibly walking over it. People are trying to clear things away, and this is the point where things could get knocked, a jig could get knocked, something could get knocked, and the layout's going to move. And at that point you're not going to know that it's moved until the concrete is in and it's set and we do an as-built survey. So we really want to make sure that it is as solid as it can be, and that we've got enough struts and props and things in place so that where we leave it is where it will be when we come back after the concrete's poured. Because I say, once it's in, it's very much in. Okay, next one. All right, okay, so I'm going to drop back again to Walthamstow, and just quickly, so I think it is quite a long time ago now, Walthamstow, and we have done a lot since then, but everything that we've done since then has been Delcore layout, and most of the time we've been installing one road at a time. So we'll go in one weekend and we'll do one road and then we'll do the other road. So you've got, thankfully, a fairly small layout that you're trying to install all at one go. Walthamstow was a 21-day blockade. It was, as Damien said, it took something like a day, 24 hours to set out. It was Sonneville block construction, which meant there was absolutely no adjustment on the blocks. On Delcore, you have got a little bit of adjustment that you can, like, really for the maintainer, but you've got a little bit of adjustment on the Delcore plates if you need to make small adjustments to that alignment. Sonneville blocks, there is no adjustment. Where it is where it is. We're going to stay for a very long time. We also did this all as one, so it's a scissors layout. It was the first one that we had done. It was the first deep tube PNC that we'd done in a very long time. It was all up on jigs, it was all there, and we had to set all of it out, all the legs, all at the same time. And as you moved one bit, another bit moved. And as I say, we had we had acro props all down each side, but if we were trying to make a movement across the layout, we would be trying to push it from one leg and push all the way across. Actually, Vid, if you go to the next slide, I think that gives you, yeah, because when I saw the design drawing to start with, when I really looked it up, I was like, oh, it doesn't look so bad, just this little scissors. And then I opened the 1 to 50 and thought, oh, there's an awful lot of there's an awful lot of stuff on that design. And it was big, it was heavy, it took a long time. I might be slightly scarred. I don't have, actually, Vid, can you go to the next one now? This is the only photograph that I have from Walthamstow. I'm pretty sure it's Walthamstow because I'm pretty sure that's Jim Bushell. And I think he left before we did any of the other ones. Clever man. So this is the only photo that I have, which clearly is when it had calmed down quite a lot. And this was probably right at the end. I was a bit busy during the rest of it to take any photos. So yeah, Walthamstow was a big challenge. And then a bit onto the future. So I didn't really talk about it before, but only talking about the dozer machine earlier. We now also have the 3D excavator. So that's one of the innovations that we're trying to bring in. It works very much in the same principles as the dozer. So at the moment, I think we can only use it as GPS. We're working on getting it used using UTS, which will be fantastic. It would be a really useful thing to add to our arsenal. So there is that we're doing already. A few other things. So I put in a picture of a drone because everybody loves a drone. We have used them in terms of design surveys. So I don't think it wasn't a design survey for ITT. The first ones that we've done was, see, I want to say this year, but I feel like maybe it was last year. I don't know what year it is anymore. But this was a company called ABA. It was over a depot, I believe, that we flew it. It is worth doing for certain sites. If there is an awful lot of detail and you can't get access to a site very easily, for example, a depot, then you can capture a lot with this technology. But it took us about 3 months, maybe more, to get all of the permissions. We had to do letter drops. There is an awful lot of people to get permissions and approvals from. You can't just go out there with a drone and start flying it above railway track. People get very, very upset. You definitely can't do that. So there's a lot of work that goes into being able to do the drone surveys, but they're definitely worth doing for some sites. The other thing there is an inertial measurement system on a trolley, which again is useful in some places, but it's a very, very expensive bit of kit. It means that you need to use less control, less survey control out there, so you can do long distances in short amount of time. It's good for recording geometry, because relative geometry it can pick up very well. In terms of the absolute position, so where that track really is in the world, it's less accurate at the moment, although it is getting better all the time. So for deep tube PNC, it definitely hasn't got the right accuracy, or for deep tube generally, it hasn't got the right accuracy because we're looking for very tight tolerances. But for other places, potentially further out on the network, then it may have a use. So we're constantly looking at all this stuff, and we may use it in the future. And I think that's the end, and thank you for listening. Okay.
Thank you, Alison.
Any questions?
If anyone does have any questions, please do write on the chat.
I have run over slightly, sorry, there's a lot of waffling.
There isn't any questions coming through the chat, so I will just pass it on to Damo.
Cheers.
Thank you.
All right. Thank you, Ali. It's not like you'd overrun.
No, thank you.
That was very informative, and it's great to detail the challenges that we face. So as an engineer, I always survey, as far as I knew the survey team, I didn't consider anything outside of a verification survey, site at the weekend, and a red line drawn. But obviously, you cover a whole plethora of stuff. So besides, and it's nice to see a photograph of me actually working on site. As you did say, work would be a strong word.
Working.
But I was definitely watching someone do something very important. But it's great to see the Orange Army at work on all the photographs. And like a lot of people sitting at home now, working from home, it's sort of ran its course, and we can't wait to get back on the site. So Walthamstow, the major success that you showed there. Pete Brown said he had to have his boots rethreaded 3 times during that closure. So there's some major effort put in there, by a lot of people. So the fact that we reassess the process shows that we continuously adapt and overcome. If we hadn't, Camden would have been an unmitigated disaster. So again, ITT right into the challenge. So that's good. So these knowledge sharing sessions, the idea is to create continuous improvement through feedback, promoting best practice. So please keep any ideas and any input coming in. It does capture the absolute unique, and I keep using that word unique, ITT expertise that we have. It is unique because we have unique challenges. And again, that presentation has demonstrated again what a unique challenge it is renewing the tube. So thanks everyone for tuning in, and looking forward to the next one, which is going to be by two of our most experienced members of staff. Lee Hollett said they have a combined experience of over 150 years between them. I'm not sure. Paul Haynes and Lee Hollett will be detailing the importance of the delivery manager's role. On a serious note, these lads have forgotten more about railway delivery than most people think they know. So thank you for your continued support and help spread the word on this platform. And it's good again to touch base with everybody and see everyone on a Friday on a regular basis. And keep the suggestions coming in. And slán for now. Thank you.
Cheers, Damien. Thank you.
Cheers, Ali. Thank you. Well done.
Well done, Ali.
Thanks, so cheers, Ali.
Well done, Ali.
Cheers,
Ali.
Thank you.
Demi, you still there?
I am, yes.
That was really good, Ali. Nice one.
Nice one. Cool. Thanks. Yeah.
Yeah, that's one of the better ones, I think. To be honest, I
Oh,
think you're rivaling Dan O'Noose for his deep tube. It was a good one.
Yeah. I think I saw Dan's actually. It was good. I haven't managed to watch many of them, to be honest, so I'm going to try and make more effort.
I'm
They are really good.
They're a bit of crack too. I enjoy doing them.
Yeah.
You know what I mean?
And it's good having the quiz in there as well. Like to just sort of break it, like you say, break it up and like line it up a bit.
Yeah.
It's